Now everybody see the Fourier series. Now we are moving to find what are the coefficient of Fourier series. Here are the coefficient formula of Fourier series A0, AN and BN. So a signal used to have the 360 degree, right? One cycle is 360 degree. That is twice pi. So if you want to find out the A0 in terms of angle domain, we can say angle scale, then we write down 1 over twice pi, 0 to twice pi x of theta d theta. 0 to twice pi x of theta d theta. Okay. In this case, the signal should be positioned from 0 to 0, start from 0. Okay. Pi, okay. Pi pi. Okay. So the amplitude is this one, and it starts from 0. In this case, the formula going to be 0 to twice pi x of theta. X of theta means this function of the signal. X of theta is the function of the signal. In case of sine wave, the function of signal will be the Vm sine theta, right? So if the signal starts from minus pi to pi, still it is a twice pi. The limit is same limit, minus pi to pi, and 0 to twice pi, limit is same, twice pi. Okay. So the signal formula is going to be the same. So 1 over twice pi minus pi to pi x of theta d theta. This is based on the angle scale, because T is the one cycle period and one cycle is twice pi, right? One cycle is twice. So the formula, both formulas same. Just the scale is different. So in this case, okay. Although it's not perfect terms, but similar you can think this going to be connected here. Okay. Okay. So here going to a T. So this is one cycle. So the A0 becomes 1 over T and 0 to T x of T dt. This is going to be the formula of A0. In case of AN, the similar way, the angle is 1 over pi, 0 to twice pi x of theta cos n theta d theta. In terms of time scale, 2 by t, 0 to t, x of t cos n omega t dt. So you can compare with the A0. What is the difference AN? A0 was 1 over twice pi, 0 to twice pi, x of theta d theta. Here is 1 over pi, is going to the half.
Yes,
0
sir.
to twice pi, x of theta cos n theta d theta. Why here is AN is half? The reason behind it, if we take the AN for full cycle, so such as this cycle.
Sir, first line, sir. Can you hear me, sir?
First line is
Sir, how the integration limit is, sir, minus pi to pi, sir.
minus pi to pi. Okay,
Yes,
okay, minus pi to pi, then signal going to be start from the left side this way. So remember, here is in the video you can see maybe the different. That will be the pi. Okay. That will be 0. Whenever theta. Okay. But remember, this is the not t. This is theta. So it's clear. The first coefficient a0. Second coefficient is an, and that an always will be half cycle calculation. Half cycle calculation for the averaging, not for the limit. Remember, not for the limit. It's averaging, because that what I want to say, if you consider the sine wave, they are the symmetrical, right? Positive half cycle and negative half cycle, both are symmetric, isn't it? So in case of symmetry, if you make a average, there's gonna be the 0. Understand? Because here is positive, here is negative. Above the reference line positive, below the reference line is negative. But they are the identical. So in identical, the positive and negative become 0. That's why for averaging, an becomes half cycle calculation. Okay, 1 over pi. But limit is same, 0 to twice pi. Understand?
Yes, sir.
So in case of time base, what was the a0? 1 over t. But in this case, 1 over t divided by 2. Isn't it? 1 over t divided by 2. That means 1 over half t. So that 2 going to be in upper of the t. That's why 2 by t. So 0 to t, x of t, or n omega t dt. For bn, similar. For bn, similar. Just we need to change sign terms. That 1 over pi, 0 to twice pi, x of theta, sin n theta, d theta. Equals to 2 over t, 0 to t, x of t, sin n omega t, dt. These three coefficients you need to find out for Fourier series. After that, you will make a series. Because if you see the previous slide, here you can see the series already ready. If you have an, bn and a0, you can make the series automatically. Because in that case, the frequency number will be the only change. Frequency number is going to change. Just you need to put the coefficient only. Understand? So the finding coefficient is an important work in Fourier series. If you do mistake here, then you cannot have the result correctly. After this, anyone has any question? Do you have any question?
Summation of plane E.
Oh, this is another. Just I am asking up to your question.
Yes, sir. I want to.
Yes, Jim, please ask. What is the question?
In this slide, A0 is equal to 1 by 2 pi, and integration 0 to 2 pi. Yes, sir. Then the second line, 1 by t, integration 0 to t, sir.
Yes.
What does that mean, sir, actually? 1 by t is 2 pi, t is equal to 2 pi, and 0 to t is equal to, sir, 0 to 2 pi, sir.
Yes, t equals to twice pi. Look at this diagram. Then one cycle, one period is what? One cycle period is t.
Yes, sir.
And in case of angle, what is the one cycle? 360 degree, and 360 degree means 2 pi.
2 pi. 2 pi.
Is it clear?
Yes, sir.
Any more question?
No, sir.
So here I want to give you another clarification. If your cycle is up to pi, that means 0 to pi, then an will be what? Half of that cycle, isn't it? In this
Yes, sir.
here. Here is, in case of full cycle, 1 over pi. Then if the limit is half cycle, then that coefficient, the front coefficient will be again half, right? So 2 by pi. Everybody clear?
Yes, sir. Yes, sir. Yes, sir.
So remember this limit. To solve the Fourier series, you need to find out the coefficient correctly and select the function correctly, select the limit correctly. If you do these three things correctly, you will not have a wrong answer. You will have the correct answer. So next formula is x of theta summation of n minus infinity to infinity Cn e to the power j n omega t, where Cn equals to 1 over t 0 to t x of t e to the power minus j n omega t dt. This formula is called the exponential form of Fourier series. So they have the same answer actually. Previous one, this one called trigonometric form of Fourier series, and this slide one is called exponential form of Fourier series. So actually e to the power j n omega t equals to cos n omega t plus j sin n omega t. Understand? That's why the exponential form, if we make the exponential form, it is much easier than trigonometric, but solving Fourier series, the trigonometric form is easier. Understand? Because in that case, individually, it takes time, but it can give you the satisfaction. But in exponential form, taking less time, but it makes confusion. That's the difference between two forms. But at the end of the solution is the same for both formulas. Okay. So today, up to this, if anyone has any more question, you can ask me, and we will give the attendance now.
So I want to know a thing, sir.
You want to know?
So I want to know a thing, sir. What is the similar between, sir, Maclaurin and Fourier?
Fourier and
Maclaurin series.
Maclaurin series. Okay. The difference between Maclaurin series and Fourier series.
And also the similar, sir.
Yeah. Wait a moment. Yeah, I'm in the class. Okay, no problem. So, the difference between Maclaurin series and Fourier series, if you see, they can represent some thing in different way. Such as in Maclaurin series, a series can define a combination because you can utilize, but in case of Fourier series, this defined based on sine and cosine, no other things. Understand?
Yes,
but the Maclaurin series depends on the differentiation. X prime, x double, they are the differentiation of the function. Understand? By doing differentiation, there are different types of shape of something. So here you can see the constant. Constant can be anything, but after that, ramp function, ramp signal, after that parabolic signal, they are summing up and create a one signal. Understand? But Fourier series defined only sine and cosine function, which is more easier than Maclaurin.
Yes,
Understand?
Okay. Thank you.
Did you get answer?
Yes, sir. Yes.
Okay. Thank you.
Thank you.
Now, any other question? Otherwise, we will go for attendance.
Okay, sir. No more question.
Okay, thank you. Aksibur,
Yes, sir.
stop.
I stopped recording 2 minutes ago, sir.
Okay, thank you.